all very, very experimental. If you can hear me in Teams, please raise your hands so that we can see that at least audio is working. Okay, I see hands. That's very, very good. But believe it or not, this is a prototype. We at Ideas Engineering, we are building prototypes with experimental technologies and evaluate whatever makes sense to replicate and to bring into the Excel Springer family. And if you take a look at the bottom of the screen, this is another prototype. Oh, awesome. I'm standing on the subtitles. Okay, so on the one hand, this stage that I'm in right now, this white, is one form where we can simulate part of this conference so that you have the feeling that you watch me on the stage while you are all safe at home. And at the same time, if you're not a native speaker, if you do not speak English, you can still follow these automatically generated subtitles that you see there, which are more or less accurate. As I said, it's a prototype. We are evaluating if it makes sense to go deeper in there, but they are generated on the fly. I did not type them before this talk. Okay, but let's go into the topic of COVID apps, because I guess this is why you are here. My name is Tarek. I work as an innovation engineer at Ideas Engineering, and COVID apps is one of the topics that we evaluated in the past, let's say in 2020, because it was very, very important. Next to me here in our virtual studio, I have Alex. Alex is supporting me as my operator in the control room. Alex?
Hi there.
Okay, perfect. And Alex will support me controlling all this equipment and making sure that you can all hear me. And at the end of the talk, she will take the questions that you might have from the chat. Code. This is the topic that I did not imagine in the beginning of this year that this will dominate everything that we are doing. But I guess I do not have to motivate this topic. It is relevant. It is one of the most relevant things that we have in our hands right now. And if we take a look at also experimental. If we take a look at what we can do as a high-tech society, then our abilities is scarily limited. My expectation at the beginning of this year was that we will invent amazing things and handle this pandemic record time because this is what we do, right? But to be honest, these high-tech solutions, they did not really arrive. We are now almost a year in this pandemic, and we still did not really handle the solutions. And you might have seen things like this, this weird space helmet that was invented, which is something that is quite innovative, yeah, or even artificial intelligence that might be able to identify COVID patients by listening to their coughs, yeah, or maybe this thing, maybe this thing. This thing, you might have seen this. It is a robot that supports with nose swabs. Yeah. And when I saw this, I was terrified. I call it the nose swab Terminator. And I don't know if you know this video. It's one form of innovative handling of COVID. I actually can't watch this. I really hate this, but I make you watch it. And this robot does itself. And okay, but the most powerful tool that we still have is the same that we had 100 years ago when the world was fighting the Spanish flu. And this is the prevention, right? Wash your hands, wear a mask, keep your distance. And this is still the most important thing that we do today to handle the COVID pandemic. And one thing that we try to do with high tech is developing these apps that will, or that are supposed to help us preventing the spread of the disease. And one of the first implementations came from Moscow. The city of Moscow, they implemented one of these COVID apps, but they did not do it very well. The story is that the people in Moscow were terrified of this app because it used weird methods like GPS tracking and randomized text messages with the order of sending in selfies. So when someone was quarantined, they had to download this app, and the app was tracking the people via GPS and ordered them at 3 o'clock in the morning to send in a selfie to prove that they are actually at home. And if they did not do it, they were fined with hundreds of euros. And this is was a weird thing, and there were so many people complaining that they were fined even though they did not even install the app. Another amazing example for this comes from Norway and Kuwait and Bahrain. It was another generation of COVID apps. They became famous because Amnesty International was displaying that they were violating the kind of human rights because they had very extensive tracking of people in real time. So every citizen who had this app installed was tracked by GPS in real time wherever they were going. It was nothing that want to do. Or I see titles are control room. Could you, once you refresh the browser, the black bar. Thank you, it works. Okay, sometimes you just have to kick it. But of course, we want to also take a look at something that goes wrong in this direction. And if we take a look at Singapore, for example, Singapore was the first city or the first country that was developing a COVID app based on Bluetooth. And this is a way better way of handling COVID contact tracing because it does not need the absolute position of yourself on this planet, but only the proximity that you have to other people or that your phone has to other phones. This one works. See it as experimental. So you have this exposure notification, but not the location tracking, and participation was of course voluntary. But participation was quite high because the app did not violate your privacy. And we in Europe, we have of course very, very high standards when it comes to privacy. Yeah. Comes to privacy, and that's, from my point of view, the biggest challenge for us to actually tackle this problem. We can't just do something, disregard everything about R, but this is the first thing that we have to think about. And there was a very, very interesting approach from a consortium of scientists and engineers, and it was called Distributed Privacy Preserving Contact Tracing. This is an initiative where we at Excel, Ideas Engineering, actually participated and supported this initiative. And here, the idea is that we have this full exposure notification as soon as possible, but at the same time it is fully compliant with GDPR. And there was a huge number of people participating, and so everyone was pretty sure that this is the way that also Germany would go when we develop our COVID vaccine. Okay. Sound better now?
No, not really.
Okay.
Ask for hands.
Quick question into the round. Is audio better now? Raise your hands if it is better.
Not really.
No.
One
Microphone would be nice.
So beforehand it was better?
No, now you should hear me.
Yeah, it's much better now.
Yeah,
Much better.
now,
Okay,
now I can
thank you very
see.
much.
Yeah.
You have to stay there, Tarek.
Yeah, sorry. Okay. Okay. Yeah, let's talk about what actually happens with this Bluetooth contact tracing in this architecture that was proposed by the DP3T. The idea is that when you install it on your phone generates these so-called ephemeral Bluetooth IDs, and those are IDs that are specifically for your phone. But they are refreshed regularly and they are not personalized. So even though your phone has this unique ID, you can't trace it back to your phone because this information is only stored on your phone. What your phone is doing is registering at Firebase and Apple push notification, so that on your Google phone and your Apple phone, you can use this push notifications. But with these identifiers, there's no connection to your personal data. During operation, these ephemeral Bluetooth IDs, they are spreaded, basically like you spread your germs or your virus, right? So if you sit somewhere in a restaurant and you breathe air, people around you breathe the same air, and at the same time, your phone exchanges these ephemeral IDs with the other phones. So the other phones, they do not know who you are, but they are collecting these IDs that you are spreading. These IDs, they are generated based on a seed, and the seed is something that you can afterwards use to identify those IDs that were generated based on the seed. What happens now if you actually get infected and you go to the doctor and the doctor checks and is doing the COVID test and one moment. Yeah. The doctor is giving you an authentication code based on, it's looked like a QR code. You can scan this with a COVID app. And this one authenticates this diagnosis in your app and sends out a notification to the one backend service that actually exists with this app. But with this notification, there's no personal data transmitted, but only the seed that was generated on your phone locally. Yeah, and the seed is then broadcasted to the network. Looks a little bit like this. So the broadcasting service takes now this notification of all the phones that are registered in there, even though none personalized, and broadcasts this seed of this infected person. And based on the seed, every single phone can now check if it collected somewhere in the past time ephemeral IDs that were generated by the seed. So what your phone then knows is if it was in contact with this particular person because it has an ephemeral ID that matches the seed, but not who this person was or when this contact happened. So you can't see on your phone, okay, this or that person was actually using it or sending me this, but I was in contact. And this is the only information that is relevant for me because now I know I'm endangered and I have to self-isolate. The big question, of course, is how can we actually calculate that I am in risk? Because even though I was in contact with someone does not necessarily mean that I am infected now, right? And so the algorithm developed by the DP3T people was to determine the time, the intensity, and the frequency of exposure. And for this, they used the magic of Bluetooth, and they used the properties of the Bluetooth signals. And we know Bluetooth uses the 2.4 gigahertz bandwidth, no, not bandwidth, frequency. And this one actually becomes weaker, or I mean, it's like with every signal, but weaker in a very specific pattern the more distance you have between the sender and the receiver. And the idea was, okay, this means that we can very easily detect if someone comes into very, very close proximity. And the special thing that is measured is the attenuation, even though this is not self-explanatory. We experimented with Bluetooth ourselves, and the hard thing is that the Bluetooth signal is reflected and filtered by walls or anything that is in the room. Even if another person comes into the room, this distorts the transmission of the signal. And so the question is, can we actually measure the distance between sender and receiver based on the signal strength? And this heat map that we see right here basically answers this question. On the x-axis, you see the attenuation, so the weaker the signal gets. And on the y-axis, you see the distance between the sender and the receiver. And you see on the very left side, it is quite accurate. So on the left bottom, where you have a very, very close proximity. But the moment you have a higher distance, like 4 meters, 6 meters, or 10 meters, or 14 meters, you have a very, very, very hard distortion of your values. So based on the signal strength, you have a problem if you try to distinguish between the receiver that is 8 meters away or 14 meters away. But from the health perspective, this does not matter to us at all, because all we need to know is what happens in 2 meters proximity to me, right? And this is very, very well measured, what we see here, because there we see, okay, this is the highest signal strength. And even though the signal might be reflected on the wall, it does not become increased if the signal is overlapping, for example. So by this measure, we can actually see who is very, very close to us. And for the time, the beacons are sent out in bursts, in intervals in 2.5 to 5 minutes. And because we are doing, or the phone is doing these measurements in these bursts, we can see over time to what other phones or other ephemeral IDs we had contact for a longer time. And at the end, the calculation is quite simple. We divide up the ephemeral IDs that we collected in buckets, like here, bucket 1, bucket 2, bucket 3, and we add weights to the different buckets so that we know, okay, which of these numbers are more important than the others. We can define thresholds based on the heat map that we saw, and we see that the first threshold is, for example, at 50 dB, the second threshold at 55 dB, and we say, okay, those are the critical parts where we say it is dangerous to be in this close proximity. And if we give the weights, then the third bucket gets weight 0, for example. So it does not matter if someone was if the signals of a person was higher than, or the attenuation was higher than 55 decibels, and everything in bucket 2 gets the weight 0.5, and bucket 1 gets weight 1. And with this, we get this exposure score. And if this is high enough, we get this notification, danger, you might have been infected. And now, of course, the big question is, what about the Corona Warn app? So this thing that we have in Germany. My expectation when we were developing this was that this Corona Warn app will be based directly on the DP3T architecture, but actually it isn't, or it is kind of, because the Germans, they developed this Corona app based on the Apple and Google architecture that was released close after the DP3T, and this is kind of the same architecture. They use like an early version of this DP3T algorithm, and so it is compatible, and everything that I told you so far is matching to this way, but it is not exactly what was developed there. And why are we still failing? If I study all these articles that are shown about this topic, and the statistics show that more than half of the Germans they do not want to use this app, even though we have it available. And in detail, 44% have absolutely no interest in downloading this app. 4% tried, but they deleted it. 5% wanted to use it, but it did not work. And this is something that that I also observed. Oh yeah, and 40% of the infected users, they did not report their infection to the app. So even though we have this technology, we do not use it. And even if we use it, and this is something that I observed firsthand, some labs, they are not connected yet. I mean, the app exists for many months now, but a lot of labs, they are not connected to the system. So they do these tests and they have the results, but they have no way of getting these results into the network. And there are some numbers from the telecom that are not matching the numbers from the Robert Koch Institute. So the Germans don't even know how many labs are there that are doing these tests. And so it is really questionable if we can utilize this app the way that it is supposed to be. And this was my last slide. If you have questions, I think we have like 2 more minutes. Question to my operator room. Anything in the chat?
Not so far.
Okay. Then we are almost out of time. You can contact me anytime. My email address is probably in this in the conference app. If you want to exchange ideas or some stories about the COVID apps, we are still.
I got one question.
Oh yeah.
Why was the telecom app chosen? Do you know details?
Yes and no. So I do not know details about the process of choosing telecom and SAP, but I guess that telecom and SAP, they are the biggest brands of software development in Germany, and so the government was probably wanted to have no risk by making contracts with lower software development companies, and they probably just chose the biggest players. But this is my personal guess.
And we have one comment.
Yes.
Thank you. And the subtitles were hilarious.
Yeah, at least we have this. Sorry for all the errors that we had with the audio and video and start of the stream. It's a prototype in a prototype in a prototype. It was a lot of fun. We are going to have some more talks. So if you want to see more setup failures and experiments with our equipment, just come in and we will have a lot of fun. Thank you for joining, and see you maybe in the next talk.